Okay, we're doing Chapter 11, Module 8, Conservation of Angular Momentum. We've got our key ideas here. Angular momentum initial equals angular momentum final. And in the problem I chose, I'll actually be using this formula here. Inertia initial times the angular velocity initial is equal inertial final times the angular velocity final. So I chose problem 51, this is module 8, chapter 11. A wheel is rotating freely at angular speed 800 revolutions per minute on a shaft whose rotational inertia is negligible. A second wheel, initially at rest and with twice the rotating inertia of the first, is suddenly coupled to the same shaft. What is the angular speed of the resulting combination of the shaft and the two wheels? What fraction of the original rotational kinetic energy is lost? So what we have is so this is what we have. We have a disc rotating, and we have this disc above it on the same axis, not rotating. And we just drop it down. We drop this disc on top of this disc, and naturally it's going to rotate at a different speed than what this original disc was rotating as. And it's asking us what is omega final. We can treat I just like a mass, so we'll start with I initial, omega initial, that's for 1, plus I initial for 2, omega initial for 2, that's this disc here, is equal to I final for 1 times omega final for 1 plus I final for 2 times omega final for 2. Now we know that this was originally just at 0, so it was not rotating at all. So then we have I initial 1, omega initial 1. Now, once this disc dropped on top of this disc, they're going to rotate at the same speed. So we're going to have I final 1 plus I final 2 is going to be omega final. This is what we're looking for, so we'll solve for that. Omega final is going to equal to I initial 1, omega initial 1, divided by I final 1 plus I final 2. And we're told in the problem that I2 is twice 2 times I1. It's twice I1. So we can say I initial 1, omega initial 1, And this will be just 3I1. Three initial I1. The I's will cancel, and what we will have is omega initial 1 divided by 3. Now, so the problem gives me omega initial is 800 revs per minute, and we're going to divide that by 3. So we have 800 revs per minute divided by 3, and that's going to equal 267 revs per minute. Now part B asks what fraction of the original rotational kinetic energy is lost. K equals 1/2 I omega squared. There's a direct relationship between K and omega squared. That's for I1 plus the combination. So I can use this to find out what fraction is lost. I can use the 267 and the 800. We just set it up. We'll say 800. And since all the units are going to disappear, I'm not going to put the revolutions per minute there. Minus 267 divided by the total, 800. This is going to give us the fraction that's lost. So let's do this. Minus 267 divided by 800 equals 0.66, and we just round that up to 7. That's the amount of fraction of kinetic energy that is lost.